So the last video was really well received, and there were a lot of questions that came out of the last video. We're going to cover 4 things in this video. They're directly related to questions that were asked. First one is, what is auto-tuning like? I made some kind of hints towards it, and I'm gonna go ahead and auto-tune one of my axes. In fact, I'm gonna auto-tune the y-axis, not the z, but the actual y. We are also going to do some rapids with some various accelerations so you can see what those are. And then I'm going to show you why I back off of the accelerations the motors can handle, but I don't feel comfortable that the aluminum frame can handle, which to no fault of CNC router parts. This is a solid machine. You can't put too much torque into any system. So, just finding that balancing point. Lastly, there were some questions about cutting circles and how much torque is involved in cutting. So I'm taking some scrap red oak I have, and I'm just gonna cut a circle, 5.5-inch circle out of it. We're gonna use adaptive. We're gonna do pretty aggressive cutting, 100 inches a minute, adaptive clearing, and I'm gonna show you the finished results of that. Right, so I think what we need to do is get started. In order to bring a ClearPath servo to life, you must send it through auto-tune. All right, so all joking aside, let's go through this. First thing I'm gonna do is I'm gonna load a known good configuration, and then I'm gonna save it in a new file name. Now I already went through this process once, so I'm gonna save over a file already made, but if you're new to this, you're not actually going to have a configuration, but do save your configuration when you're done. We'll talk about why on the flip side of the tuning. So here I am loading this configuration. Give me an error message because I've already have this configuration. Right, so we're going to jump up to setup. Now I'm narrating what I did, so totally going to screw this up and run over to advanced for some reason, and then jump over to setup. Click on auto-tune. Big warning message. Listen to the warning message. Respect the warning message. Be aware. Click next. You're going to use 100% of your torque unless there is some ridiculous reason not to. Just use 100% of your torque. Now, it's an axis. It has an end, so limited motion. Right? You can only go so far in either direction. And we're gonna choose to just move it physically by hand. So I'm gonna walk over and I'm gonna basically move the servo to the 2 ends that it can move to, and this is to help give it an idea of how much room it has to work. It's going to use that to figure out how far across the gantry it should go, a couple of the things. So we're good there, and we're just going to review our settings. It's bidirectional, 100% torque, and it's going to do 50 revolutions, roughly 50-inch range is what it's said it has, calculated it has. All right, some more warnings. I'm going to click next as soon as we've gone through those warnings. Basically, it's just saying, hey, it can take 10 to 15 minutes, maybe as much as 30. Reality is this thing took 5 minutes. We're going to compress it in time here when we go to actually watch it. We click run, we sit back, and we enjoy the show. There we go. This is going to kick off now. You're not going to... You can hear it. Listen. Shh. Hear that? Oh, yeah. Now you can start seeing it. It starts with really, really tiny motions. Again, square form. That's what the knocking sound is. It's a square form. So it's just hitting with as much energy as possible. Just tiny, tiny, tiny motions. So you need a little bigger. A little bigger, a little bigger, a little bit bigger now. Look, there's a song there somewhere, right? You can actually see it starting to shake my table. Now you got to think about it. This is the first time you've ever made your CNC move, the first time you've ever moved these servos, and this is what they do. So let's get a little music. We're gonna go up to 5x speed. You just sit back and watch it run. It does some rapids at the end, so when the music stops, it's going to be a little bit more stuff. I'm going to bring it back to normal speed so you can see it. So, right on, let's do it. all those clicks to the square form. And obviously running 5x is a lot more of them compressed. I'm going to mention, if you're watching this and I don't want to see it at 5x, I want to see it at real-time speed. You know what? Put a comment down. I'll post this video at normal speed. It won't be very exciting, but you know, if you guys want to see normal speed tuning, I'll do that for you. I think the music's a good pick for this. You know, it's so exciting. Maybe not. It's what I had. We're about to do some crazy rapids here and finish this up. It doesn't look like it, right? It's like 48%. It thinks it's almost done. And it like just does a couple things and then it says, I'm good. Just about to hit the end. The end. Now let's talk about what do we do with it. What do we do with the tuned motor? That's up next. Alright, we finished our tuning. Obviously, next thing we're doing is close the screen. This screen here, it's just basically telling you need to disable the motor before you can leave here. You can jog the motor one way or the other based on, you know, if you need to move it. Once you're done there, the three things you got to do. The next screen is going to talk about two of them. You need to set your motor ID and you need to set your mode to step and direction. So next screen here is going to talk about fine tuning. We'll talk about that in a second, and the motor ID. So set your motor ID, set your ID, save your settings. Once you've done that, go ahead over to your file server. Here's your settings. You want to go make 2 copies of that Y setting you just created or your gantry setting if it's your X. First one we're going to name X axis. And the second one we're going to name XS axis. I'm going to name it. These could be Y, S, and Y. It depends on how you label your gantry. My dual axis is X. That's how I run my machine. So X and XS. Once we have those set, we're going to go ahead and start up ClearPath and plug in the first motor. Could be your slave, could be your master, doesn't matter. We're going to plug in one of the 2 motors. Now that you're plugged in, ClearPath's going to find the motor. In my case, the motor has configurations, which is fine. It's going to pull all the configurations from the file, but in this case, your motor would not necessarily have configurations. So we're going to, first thing we're going to do is go load the configurations we want to use. So this can be under File and Load. And you're going to pick that XS because I'm working on XS. You pick your X if you're working on X. Doesn't really matter. Again, consistency is also important. I'm going to load that file. I like XS to be reversed. So what I'm predominantly making sure is that reverse direction is checked. So it's going to load up the motor. You notice it says Y-axis here. We're going to change that label here in a second. But we want to make sure we're reversed. So we're going to double check the settings. Let's go ahead and change that motor ID. Again, this should be XS because it's our slave. And once we've set that value, then we're going to double, triple, quadruple check that this is the motor we want to reverse. Your gantry motors, unless you're doing really funky things, always have to be reverse of each other. That's just the nature of how gantries work 99% of the time. So, paramount that they are reversed. So I like the slave to be reversed. When we load up the other one, it will be the other way. So that setting's in place, and we're going to go ahead and save this file with the right name and in the direction we want the motor to move in. And once we've done that, we've saved that file, we're going to move the USB cable to the other side of the gantry. go ahead and plug in here. Once we're plugged in, again, ClearPath will find the motor and load up its configurations, which if it's a brand new motor, again, you won't have any configurations to load up. That's okay. That's not a problem. So it's going to load up the motor, and we're going to go ahead and load up our X configuration because we were just working on XS, so obviously this is the X, it's the other motor. We're going to load it up, we're going to change that motor ID, and then we're going to make sure that we turn off reverse direction because our slave is reversed. So once these configurations come on, turn off that setting. Never, never, never forget to do that. And go ahead and set that motor ID. Now we have our gantries. Once this is set, we'll have our gantries. Now, when you set the motors reverse here, you do not need to reverse them in your CNC motion controller. So don't reverse them there. You've reversed them at the servo level. As far as your motion controller is concerned, they're the same. Once that's saved, now you can move your gantry around. You can tune things. So if you don't like how it's moving, if it's too noisy or too soft, you can change how the servo works here with this fine tuning setting. Whenever you set that, if you're working on the y-axis, it doesn't matter. But if you're working on the x-axis, you have to remember that number was set to. In this case, it was 9. You need to save that setting. You need to move the USB cable to the other side, and you need to set that one as well. So always keep your x-axes on the same configurations. The only difference being reversing direction, and we're good to go. That wasn't nearly as scary as I thought. It's a lot less scary and a lot more auto-tune. All right then. Let's move on. Moving right along, what we're going to do next is we're going to do the rapids testing. So I'm going to run the machine just going to corners and going around. I'm going to do it at various accelerations. By default, I leave the machine at 45 inches per minute per second. So that's the acceleration. For the purposes of this test, I did like 45, 60, 75, 100, and 200. So for 200, it's getting up to 1,200 inches a minute pretty darn fast, which is the rapids rate on this machine. It's 1,193. I did some math somewhere at some point, decided 1193 was as close to 1200 as I wanted to get, which is silly. I could have just gone to 1200. Then after that, I'm going to show what I mean by too much torque. So I'm going to do basically a back and forth on the x-axis at 200 inches a minute versus 45 inches a minute. So you can see how much 200 inches a minute when you're moving a 170-ish pound gantry back and forth can actually cause the whole frame to flex quite significantly for, your average workshop. This is not, again, this has no bad marks to this machine or this frame. It's totally that you can put too much energy into a system. That's perfectly fine. So anyways, let's watch that. That's pretty cool. Right. Let's set up the test here. We're going to go back and forth at first 45 inches per minute acceleration, max 1200 inches a second. We're going to go 10 inches, then 20 inches, then 30 inches. And what I'm showing is the vibration. So really what we're looking at is the motor torque involved in stopping at these various accelerations. And what does that do when it's just going to come in as fast as it can and stop? So obviously here, this is what I run my machine at normally. A little bit of vibration, not too crazy, but there's a little bit there. Now check out 200 inches a minute. It's a big difference. So here we go, 200 inches a minute, and you can instantly see, check out that vibration. The whole table is shaking back and forth. Just a lot of motion going on there. It's pretty crazy. What we're going to show next is the same 200 inches a minute, but I filmed this actually at 120 frames a second. So what does 200 inches a minute look like at 150 frames a second? 20 frames a second. And this is what it looks like. So here you can really see what are all the systems moving. I want to put a reference line up for you guys to see, and then here in a second I'm going to show you how much flex is really happening. And so there's that second. That's a total amount of flex. It's quite a bit of motion. Eighth of an inch or so. I mean, you know, from the perspective of the camera. But yeah, not insignificant. More than I would feel comfortable letting work move for sure. And again, this is all the torque of the motor stopping, right? The motor is engaging to stop the work. There's nothing else involved in braking. It's just the motor. So there you have it. That is too much torque for this system. These motors are torqueier than they need to be, except like I talked about earlier, they have reasons to be this heavy in regards to inertia. Next up, let's make some cuts and let's show you what cutting does to the torque graph. All right, we're going to do a cut test. Cut test is a little longer than we can screen capture for, but we're going to have the torque running on the x-axis while we're doing this. We're going to take a piece of wood to make our cut test. 1/4 inch bit. Screw for hole down. Double steel for hole down. And we're going to cut a 5.5 inch circle. Now, obviously, wood is not going to be perfectly exact, but we will take calipers of this to see how close we get to 5.5. Probably going to be very close, but again, we're going to take calipers to wood. Chances of us measuring exactly 5.5, margins of error and such. Either which way should be a good test, and we'll be able to see how this is cutting. I'll note, we'll go through the cam because I'm going to be pushing this pretty hard. Right, let's get the cam out of the way real quick. This is our piece of wood. We're going to do a 2D adaptive with this 1/4 inch bit. Let's talk about that for a split second. I said I was going to be aggressive. And to me, this is aggressive. For those that don't think so, put a comment. Tell me why it's not aggressive. All right, so load is 1/10 of an inch. So that's 40% engagement on the edge of the bit. We're also doing one pass. And this is a 1/2 inch here, so we're doing double diameter, 40% engagement. We're going to run at 22,000 RPM and 100 inches a minute. That's probably a little bit kind of, probably maybe could have tweaked these numbers to get more clearance, but that is still pretty darn fast. And then we're just going to contour around the edge twice, because what I surmise the request is they want to see how smooth the edge of this circle would be. Now 6,400 steps a rotation and roughly a rotation an inch. Should be really, really, really smooth. That's what we're going to cut. That's what we're going to find out. So let's go find out. All right, first off, check out those chips. So it was taking meaty chunks. You'll notice in the video, the torque was essentially not a factor. It wasn't affected at all. Real quick, I'm gonna go ahead and get in close here, get in tight. And you can see it's really smooth. Like you don't even need to sand it smooth. It's so no faceting. If that was the question about cutting a circle, and I made a 5-inch circle. It's pretty big for the intention of exposing any faceting if there was any. But no faceting. Very smooth. And now let's grab the calipers and see how close it came out. We're not going to be able, I mean, if we're within 100th, that's actually pretty impressive for wood. And, sorry, it's actually hard to hold. We are, yeah, I said within 100th we'd be pretty good. It looks like, you know, it's not a mic, but we're within 200ths. That's pretty good for wood. On the edge of my calipers, what can they actually measure? Yeah, I mean, I'm having a hard time. Let's call it 1.5 because I seem to be able to consistently get in that area, that ballpark. So 100th off. There we go. 100th off, if you can see that. I hope this was valuable to you guys. Looking back at the 4 things we did, I think the auto tuning was probably the most surprising to me personally. I knew how it was going to react when I did the torque and the rapids tests. That was for you guys, but I was surprised at how uninteresting auto tuning was coming back to it in reflection. And I think kind of thinking about why that might be, when you're building a home machine like this is a CNC router parts kit. It shows up in a bunch of parts, you put it together, and you're putting something that is slightly unknown like a servo on here. The first time anything moves is when you auto tune it. And so having it make those tiny motions, those square form clicks where the whole machine does vibrate. I mean, it does, you hear it vibrating, and it does those rapids back and forth, and you're not really 100% sure what's going to happen next. It's a lot more intense, just the lack of knowledge. So hopefully you watching an auto tune happen will remove some of that hesitation from you, and it'll be, you know, just something you do rather than perhaps something you have apprehensions towards. The rapids results, exactly what you expect. The motors are more powerful than the aluminum. That being said, they are the right mass of motor for inertial reasons, as I mentioned earlier, that they are in fact, you know, the right motor. It didn't go wrong. I didn't overbuy by significant amounts, maybe $200. Lastly, the cuts were beautifully smooth, and that's to be expected. Cutting 64, cutting, you know, had smoothing turned on, and it was a few thousandths, you know, range. I'm not sure why I was 100th larger than I should have been. I'll have to go into that someday, fix that. I think I need to tune my machine a little bit more. I tuned it over 1 inch, but I think I maybe need to set up some tuning over like 10 inches or something, so I can really, you know, figure out, you know, if there is any variation. Maybe I tuned variation into it because I was tuning for 1 inch. So interesting thing to solve. Not related to the servos at all, or the machine, just my tuning of it. Last things last, there was some private conversations. Some people emailed me saying, hey, you kind of had this weird moment, and and I want to get some motors, but it made it sound like maybe their customer service wasn't cool or something. Their customer service is totally amazing. I paused in the sentence kind of weird, but yeah, just to clarify for those people who shot those emails to me, and I replied to them specifically, but you know, they were worried they were going to, you know, air dirty laundry publicly or something, and there's no dirty laundry to air. It really are solid motors. Just like I said at the end of the other one, I do not regret this decision. Hopefully this provides enough information for you guys to make educated choices. Moving forward, I'm totally reusing the lab coat. I think from now on, whenever I do a product review of any kind, wearing the lab coat, because I thought the lab coat was fun, and you guys are going to be subjected to it. Right. Thank you guys again. Subscribe, comment, you know the drill. Oh, by the way, 100th subscriber, which is, I know, tiny 100. It's not much, but it's a start. So thank you 100 people who have decided that this channel is worth following, and maybe I'll say the same thing at 1,000 and 10,000, and who knows from there. You know, we'll see. Till next time, guys. Later.